question 5. So two points are given in R4, and we have a line segment PQ, and we are looking for a vector which is parallel to the directed line segment PQ. So while the vector which is equivalent to this, so equivalent vector is found by doing, okay, this is a point, Q is a point, but you take it as a vector, or let me just do without vector notation. Corresponding components of the end point, here this is end point, this is starting point. First component of end point minus the first component of the starting point. That will be the first component of the equivalent vector. The second component of the end point minus the second component of the first one. So 2, 2. 1 minus 3, and -4 minus -4. So what we get here is 3, 0, -2, and well, what is it? You subtract same numbers, you always get this 0. This is the equivalent vector to the directed line segment PQ. The question is asking find which one of the following is parallel. So parallel means that it is multiple of this vector. So let me just write this U. So the question, I can rewrite it as which one is a constant or scalar multiple of U. Scalar multiple means what? You multiply a constant to U, you get that vector. Something interesting, if you multiply C to U, you get 3C. C times 0 is 0, -2C, and C times 0 is again 0. So the vector we are looking for is going to have the second component and the fourth component equal to 0. We have only 2 such vector out of these things. So these are null. Now, the question is that which one of these guys is parallel to U? Well, see here, the third component and the first component are going to have different signs. 9 and 6 have the same sign, so this cannot be the case. Well, I'm now claiming that B is the answer, but how is B answer? If you let C to be 3, sorry, -3, then CU is equal to -3 times 3 is -9, 0. -2 times -3 is just 6. And 0. And this is exactly the option B that you saw. So going from the directed line segment to equivalent vector was the first step, which we do the components of end point minus components of the starting point. And well, then the other thing was that which one is parallel to that equivalent vector. Is there any question, any comments?
Yeah, I have a question.
Sure, please go ahead.
I was doing like some prep courses with Prep 101, and they mentioned that you might have to like identify like parallel, perpendicular, and identical to like directed line segments. Well, that
okay, I don't know who is teaching 101 but definitely that person is not the person who's teaching the course.
Okay.
Okay. So parallel can have the definition of parallel is this: it is multiple of u, a scalar multiple of u. That scalar can be 1, which those people like to call it identical, but that is parallel still. And it is to my full surprise that why these guys are doing this kind of new notation. Obviously, they don't know very well the course. And for us, there is no identical. Well, parallel, every vector is parallel to itself. Let me tell you this way.
Okay, thank you, because that was kind of confusing me when she was explaining all that stuff. So
okay, but it's clear right now, yes?
Yeah.
Parallel means that it's just multiple of the other one. That's it. Any other question?
Yeah, I also have a question.
Yes?
Is collinear the same concept as parallel?
Yes. For the vectors, the notation that we usually use is collinear, okay? But when it comes to one directed line segment and one vector, or one vector and a line, or two lines, we use the word parallel, okay? So this, but if you see in a question asking if these two vectors are parallel, just consider it as collinear.
Okay, got it. Thank
Okay.
you.
Okay. But as I said, the exact meaning of collinear in this book is supposed to be used for just two vectors. If there's a vector and another object like line or line segment or all these things, then parallel is the word we use for it. Okay. So then I will move to the question 6.